I'll start like that. So yeah, now something slightly different. So the title of the talk was actually given to me by Chris, but I had sort of hoped to sort of talk about a slightly different aspect of work. So we had obviously a lot on sort of solid state related work of Malcolm, AIM-Pro and Malcolm's group. And so I sort of have a slightly different focus, although I was employed by Malcolm also to look at some of the defects in graphitic systems. I sort of added another dimension, if you want, and looked at some of the aspects of C60. So I want to start going right back when I was a first-year undergraduate student in Freiburg in Germany. And in one of the first weeks, I sort of was browsing Nature and basically came across this very paper, I guess most of you are familiar with. And I was absolutely fascinated, having sort of wondered about cluster chemistry, and that was one of the areas I was hoping to maybe work on in the future. And coincidentally, in the same section, the letters to Nature, was a letter from Edward Teller that looked at climate change and sort of nuclear winter and the connections there. So I think that there's also like a lot of soot and carbon, and as you will see, that this sort of later plays a role. And then after a few years of studying in Freiburg, and I was getting a bit fed up with so very sort of synthetic chemistry type of approach, I sort of looked for new horizons and started to sort of apply for a position or sort of a studentship at Sussex. And so when I arrived there in October '89, so one of the things that really stuck in my mind was lectures by Harry Crote together with a colleague from the astronomy department, and talked about sort of what happened to carbon and soot in space, and sort of red stars blasting out soot into space. And crucially, sort of in that year, I also met Jonathan Hare, who was actually working with Harry Crote, and I think he became very important in this whole sort of Fullering history. And if it hadn't been then for the joke that happened towards the end of my year at Sussex, I would have sort of gone back to Germany. And one evening, just before the BSc examining starts, a lot of my flatmates in Brighton all sweating over sort of revisions, and then someone said, "Oh, are you coming tomorrow then to sit the BScs?" And I said, "Oh yeah, sure." And so I did, and so I sat the BScs, and on the strength of this kind of haphazard kind of results, I wasn't allowed, and I thought that was a really great pragmatic way of the Sussex University system. They let me sort of start on a PhD without any sort of formal other degree. And sort of then in the coming years, I was working on potential energy functions with John Morrell, and then out came this sort of bombshell paper, sort of just ahead of Harry Crote having also, and Jonathan Hare, isolated C60 here at Sussex in macroscopic quantities. And so they got beaten just very slightly by a group of Kretschmer and Huffman, and obviously that really inspired a lot more research in this, and I sort of contributed a tiny little bit because I had sort of derived carbon clusters structures from solid state potentials, so they were fitted to some properties of carbon, including Falmer spectra, and so if I looked at C60, C70 and other clusters, and was very pleased to find that they were kind of more stable than other types of topologies. But I was sort of not so happy with some of the energetic results that are coming out. I thought, well, maybe I need to sort of do something a bit more sophisticated than using potential energy function. And this is sort of really when I sort of looked for my next postdoc position, and I found that with Malcolm. So in November '94, I started, and originally we looked at graphitic systems and the defects in them, but modeling that at the time on essentially hydrogen-terminated sort of carbon clusters, and that's what got me thinking. Well, maybe should use AIMPRO also on fullerene type of structures. But at the time, and this I think came out very nicely this morning in Patrick's talk, the computational power in those days was not such that you could sort of tackle easily a system of 60 atoms. But I managed to sort of get, I think it was a Royal Society grant to buy a Silicon Graphics workstation. And Malcolm just fortuitously also had money, so we pooled the money together and bought what was at that point really the top of the range Silicon Graphics kind of workstation, which we called Linus. And this had a power of about 300 megaflops. And I at the time, my girlfriend, who later became my wife, I sort of tried to impress her, and I think after some university event, sort of took her to the park and said, look, this is the sort of computer I work with. And so she said, oh, what can you do? And I said, wow, it's like 300 megaflops, what that means, and so I thought, okay, I'll sort of just demonstrate. So look, I can add 1 billion numbers together in like 3 seconds. So I was sort of writing a quick Fortran program, and I guess in the sort of haste on this, I then forgot to switch on the optimizing flag, and then 5 minutes later, I think she got very bored and said, well, that's okay. But so we used the SGI workstation and the other system that we had at the time very thoroughly to investigate the graphitic defects and fullerenes, and I think that was also the time the first sort of indications of the spiral interstitial started to emerge, and I looked at kind of fullerenes. And so I think this was sort of the highlight of my time of working with Malcolm. And so essentially this started by experimental paper that found that when you used carbon-13 atoms and bombarded C60 with it, then some of the carbons were being exchanged. And so we thought, okay, there must be some interesting kind of reaction going on between carbon atoms and the fullerene network. And up to then, so one of the big questions on fullerenes was, if you show this sort of beautiful icosahedral structure to an organic chemist and say, well, can you synthesize that? And despite of the symmetry, this would be a near impossible kind of feat. And then to sort of learn, that you make this beautiful molecule just by sort of evaporating carbon in a helium atmosphere. There must be some really interesting kind of dynamics going on, how you form a sort of highly symmetric cage. And also, well, there are lots of isomers which are not asymmetric and have basically adjacent pentagons. So the question is, how does such a system then really get to the point of becoming a sort of an isolated pentagon type network? And so together with this experimental observation, we then started to investigate if basically the carbon atoms that were sort of also available in the system. Sorry, this is I need to get this right. So if sort of individual carbon atoms could attach themselves to near the center to the stone whales kind of transformation and could sort of lower the activation energy needed to perform such a transformation and actually separate the pentagons. So you basically swap the position of the 2 pentagons, and if you have adjacent pentagons in a sort of not perfect kind of Buckminster fullerene, then what you would get afterwards is a separation of those. And so this is sort of summarizing the energetics of this result. So this is the sort of activation barrier for a stone whales kind of transformation. with the carbon atom basically removed to infinity. So we have basically from the, this is the C2V isomer, which has basically adjacent pentagons, and you have 4.7 electron volts, and then so you come down to a slightly lower energy structure, which is the, you know, the Buckminster fullerene, all pentagons isolated of 6.2 electron volts. Now, if you then add the carbon atom near the Stone-Wales transformation site, then, as you can see, you reduce the activation energy substantially. I mean, it's still, you know, quite high, but given the conditions under which you produce the fullerene, this was sort of a plausible mechanism how carbon atoms could basically, in an autocatalytic process, help with the formation of icosahedral C60. And so we bounced this around in the team, and so eventually between mainly Malcolm and myself, we got this paper written up. And so I thought, well, we'll give this a really good shot. Wrote a sort of very carefully crafted sort of cover letter and sent it off to Science. And he came back and had accepted it. And I think, you know, it was sort of really a very highlight of the days. And so this was just sort of happening at the sort of the final few months that Malcolm was in Exeter, and it was becoming clear that the university was not going to carry him over. And at the time, basically, a position at Sussex was becoming available, and Malcolm applied for this position, was successful, and so I joined him, and so between the two of us, we kind of started building up the group at Sussex. And so we also heard earlier that we had a lot of CPU time on, I think it was a T3 system or some sort of national supercomputer facility, and yeah, we did some calculations I was involved with on this sort of nested fullerene structure. We heard already a bit about it, so I'm just going to so leave it at that, but we successfully burned up a lot of CPU time doing the LDF calculation. And then in sort of the autumn of 1997, I'd spent sort of like 5 years as a postdoc, and I was thinking, well, I needed to start doing something slightly different. So I was sort of too keen of doing another postdoc position and having to sort of move around. I was quite happy living in Brighton. So I kind of said goodbye to academia, but sort of never quite sort of left sort of the science behind it, kept sort of a slight eye on it, and I sort of kept being in touch with Malcolm on and off. And so one thing that I sort of did, I sort of wrote up this was for a sort of a science outreach kind of publication that was published in 7 languages, and unfortunately now is sort of archived. But sort of the work on the discovery of fullerenes and the serendipity and the other stuff you can do with carbon atoms of all sort of shapes and forms. And so after sort of 10 years or so, I sort of went and started working in climate change. So this is what I'm doing now. So very much removed from C60, of course, but so still keeping an eye on what goes on in carbon kind of chemistry. And so I've written a couple of papers or sort of pieces of you know, so for young people to inspire them into science. So yeah, I sort of got sort of in a very sort of non-linear way to where I'm now. But the original reason why I came to Sussex, which was to sort of go into environmental chemistry and atmospheric chemistry, I sort of managed sort of over a long sort of contorted path to come back to, which I very much enjoy. But if I sort of look back, you know, the time I had with Malcolm first in Exeter and then also in Sussex, I mean, it was a great time. It's a great time also working with Chris and a lot of the other colleagues in in the time. Bob Jones, progress. So it was wonderful, and I'm really glad that Malcolm and I kept in touch when we're living in Exeter, and that we sort of stayed really friends after academia as well. So thank you, and thanks everyone for sort of listening to a very personal kind of skewed account of what went on with Ducky Balls. Thank you.
Well, we have time for a few questions before time for a few questions before the coffee break. Actually, where are the posters? Because
the posters will go up on the glass
in the meeting, and is the coffee over there too? Okay, so there's. So we have a couple of posters that probably a lot of you haven't seen yet because they came up fairly late during the lunch hour. So, questions to Bernd? Chris?
It's a really simple question. Do you miss it?
Yeah, it's a very good question, and I do in a lot of ways. I was sort of educated as a chemist, so obviously still having a lot of interest in chemistry, and sort of seeing this kind of field kind of explode from this kind of first paper from 85 to now, and it's fascinating. And at some point I tried very hard to sort of stay in the area and work on endohedral fullerenes, and I was talking with Bob and with Patrick about how can we sort of get good potentials to do LDF calculations of metals in the cages. But at the time, it wasn't to be, and I probably didn't have the patience to sort of wait out another few years of postdocing until I sort of kind of got my chance. And so I do miss it, and I sort of keep reading on papers, and I think every time I sort of talk about it, I sort of, so some of this sort of enthusiasm bubbles up, and some of the talks earlier touched on all sorts of other aspects. That I sort of kind of remember. So yes, but I also enjoyed what I did afterwards. So yeah, it's kind of in the balance. Thank you.
Okay, thanks very much, Bernd, and we won't